Welcome to this lesson on polygons on the coordinate plane. Please make sure you have these notes in front of you so we can begin our lesson. This lesson has two learning objectives. The first one says I can draw polygons in the coordinate plane, and the second one says I can identify the length of a polygon using coordinates. The vocabulary word that we're going to talk about is called vertices, and vertices are the point where two or more sides of a figure meet. So let's go ahead and complete this table so we can look at what vertices look like on different shapes. And the first shape that we're going to talk about is a triangle. And a triangle has three sides, and the number of vertices on a triangle is 3. So let's look at an image of it. An image of a triangle has 3 sides. Now the vertices, here's one vertice because that's where two lines meet. Here's another vertice because that's where another two sides meet. And here's the third vertice where another two sides meet. The next shape is a quadrilateral, and a quadrilateral is any shape that has 4 sides, because the word quad means 4. So a 4-sided shape. So a quadrilateral has 4 sides, and it also has 4 vertices. So let's go ahead and draw a picture of it. Here's an image of a quadrilateral because it has 4 sides. Here's one vertices, the second vertice, third, and fourth vertice. The next shape we have is called a pentagon. And a pentagon has 5 sides. It also has 5 vertices. So let's go ahead and draw a pentagon. Here's one side, 2 sides, 3, 4, 5. And then I went and labeled the different vertices on this pentagon. Notice there are 5 dots. That's where all the lines of the shape meet. Our next shape is called a hexagon. And a hexagon has 6 sides and 6 vertices. So this is what a hexagon looks like. 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. And then the vertices are labeled with the black dots. There's 6 vertices on a hexagon. The next shape is called a heptagon. Now the word hepta means 7, which means we have 7 sides and 7 vertices. And this is what a heptagon looks like. There's 1 side, there's 3 sides, 4 sides, 5 sides, 6, 7. And then I went ahead and labeled the vertices. Notice that there are 7 vertices on the heptagon. The last shape we're going to talk about is called an octagon. And an octagon has 8 sides and 8 vertices. Now the most famous image of a octagon is a stop sign. So here's an image of an octagon. It has 8 sides. And let's go ahead and identify the vertices wherever the lines meet. So 8 vertices and 8 sides on an octagon. So let's use these key concepts to discuss the following examples. For example 1, it says a rectangle has vertices point A 2, 8, point B 7, 8, point C 7, 5, and point D 2, 5. Use the coordinates to find the length of each side. Then find the perimeter of the rectangle. So the first thing we should do is we should go ahead and take these ordered pairs and graph them on the coordinate plane. So there's the location of point A, there's the location of point B, there's the location of point C, and there's the location of point D. So now that we've graphed it, our job is to figure out the distance between each vertices. So the first thing I'm going to do is I'm going to find the distance from point A to point B. Notice we can sit there, we can count the squares. 1, 2, 3, 4, 5. There are 5 squares in between point A and point B. But here's another way to figure that out. Let's look at the ordered pairs for point A to point B. And notice that the y-coordinates are the same. So I'm going to ignore the 8s. And I want to find the distance between the x-coordinates. So I'm going to draw my absolute value signs. And I'm going to subtract 7, which is one of the x-coordinates, and 2, which is the other x-coordinate. So if I take 7 minus 2 with the absolute value signs, that becomes 5. And the absolute value of 5 is just 5. So that's the distance between point A to point B. Let's try another one. Let's find the distance from point B to point C. So yes, on this grid we can go ahead and count. There's 3 boxes in between point B and C. But let's use the coordinates to figure this out as well. So here are the coordinates of points B and C. Notice that the x coordinates are the same, so I'm going to ignore that for now, and I'm going to find the absolute value difference of the y coordinates, the ones that are different. So let's take 8 minus 5, and the absolute value of 8 minus 5 is just 3. So the distance from point B to C is 3. Let's try another one. Let's find the distance from point C to point D. So we can sit there and count the boxes in between point C and D, and notice there are 5 boxes, but let's use coordinates to figure that out as well. So notice in this problem, the y coordinates are the same. They both have 5, so let's cross that out and ignore that. And let's find the absolute value difference from the x coordinates. So 7 minus 2. 7 minus 2 is 5, and let's take the absolute value of 5, which is just 5. So now let's try one more. Let's go from point D to point A. Notice there are 3 boxes in between, but let's use coordinates to figure this out as well. So for these points, notice that the x coordinates are the same, so let's ignore that. And let's figure out the absolute value difference from 8 minus 3. And 8 minus 3 is, 8 minus 5 is 3, and the absolute value of 3 is just 3. So now that we have each side of the rectangle, let's go ahead and find the perimeter by adding it all up. So let's take 5 plus 3 plus 5 plus 3. And when we add them all up, we should get 16 units long. And that is the perimeter for our rectangle. Example 2 says rectangle A, B, C, and D has vertices of point A, 2, 1, point B, 2, 5, point C, 4, 5, and point D, 4, 1. Use the coordinates to find the length of each side. Then find the perimeter of the rectangle. The difference between this problem and the last problem is that we're not giving you a coordinate plane to plot your points. So what we're going to have to do is figure out the distance between each of the vertices. So let's find the distance between point A and point B. If I'm looking at these points, the x coordinates are both the same. So I can go ahead and ignore the x coordinates, and I want to find the distance between the y coordinates. So I have one y coordinate here and another y coordinate here. So I'm going to take the absolute value and find the difference between both y coordinates. So 5 minus 1. And then I can take 5 minus 1 and take the absolute value of 5 minus 1, which is just 4. So the distance between point A to point B is 4 units. Let's try another one. So now let's find the distance from point B to point C. So I'm going to look at my coordinates. Notice that the y coordinates are both 5. So I'm going to ignore the y coordinates for now and figure out the distance between the x coordinates. So I'm going to take the absolute value, and I'm going to find the difference between the 4, which is this, and the 2, which is the other x coordinate. So 4 minus 2 is 2, so the absolute value of 2 is just 2. So the distance from B to C is just worth 2. Let's look at another one. Let's find the distance from point C to point D. So notice the x coordinates are now the same. So I can go ahead and ignore that and find the absolute value difference of 5 and 1, which are the y coordinates. So 5 minus 1, take the absolute value of that. 5 minus 1 is 4, and the absolute value of 4 is just 4. So the distance from C to D, those vertices, is 4 units. Let's try one more. So point D to point A, notice that the y values are the same. They both have 1, so I'm going to ignore that. And I'm going to find the absolute value difference of 4 minus 2. And 4 minus 2 is just the absolute value of 2, which is just 2. So from point D to A, the distance is 2. So now we got to figure out the perimeter of this rectangle. So we got 4 sides, so we have to add them all. So 4 plus 2 plus 4 plus 2. And when we add them up, we get 12 units long. So pause the video, complete the guided problems, and we'll discuss the answers in class tomorrow. Notice I have 2 guided problems on the slide, guided problem A, guided problem B. For example 3, it says each grid square on the zoo map has a length of 200 feet. What is the walking distance from the monkeys to the elephants? So if you are at the location where the monkeys are, we're going to have to go from the monkeys and walk to the gorillas, and then from the gorillas walk down to the elephants. So here are the ordered pairs from the monkeys to the gorillas. If you notice, the y coordinates are the same. They both have 10, so I'm going to cross that out and ignore that. And I want to find the distance from the x coordinates. So I'm going to take the absolute value signs, and I'm going to take 7 and subtract it from 0. And the absolute value of 7 minus 0 is just the absolute value of 7, which is just equal to 7. So let's go ahead and figure out how far it is from the gorillas to the elephants now. So I've listed the ordered pairs from the gorillas to the elephants. And I'm going to take note that the x coordinates are now the same. So I'm going to cross out the x coordinates, and I want to figure out the distance from the y coordinates. So I'm going to take the absolute value sign and take 10 subtracted from 7. So 10 minus 7, and the absolute value of that is equal to 3. So if I wanted to get from the monkeys to the elephants, I would have to walk 7 plus 3 units, which was 10. However, it says each square is worth 200 feet. So each little square on this grid is worth 200 feet. So if I'm walking 10 squares, I'll have to multiply that by 200 because each little square is worth 200. So when we multiply 100 times 200, we get 2,000 feet long. So that's the distance from the monkeys to the elephants at the zoo. So pause the video and complete this guided problem, and we'll discuss the answer in class tomorrow. For example 4, it says a triangle has the following coordinates: x, which is negative 2, 1, y, which is negative 2, 3, and z, which is 1, negative 4. So let's go ahead and plot these points on the coordinate plane. So that's the location of point x. That's the location of point y. And that's the location of point z. So if we connect these vertices, we can form a triangle. So now let's go ahead and answer the question. What's the distance from point x to point y? So what we can do is we can take a look at the two coordinates. They both have the same x coordinates, so I'm going to ignore that. And I'm going to take the absolute value and find the difference of the y coordinates. So I'm going to take 3 minus 1. And when we do 3 minus 1, we get 2, so the absolute value of 2 is just 2. So the distance from point x to y is 2. Notice there are 2 boxes from the vertices of x and y. So pause the video and complete this guided problem, and we'll discuss the answers in class tomorrow. For example 5, it says there are 3 of the 4 coordinate points of the vertices of a rectangle. What are the coordinate points of the missing vertex? So if I want to make this a rectangle, there's got to be a point right here to complete the last vertex. So the point that would make that last vertex a complete rectangle would be negative 2, negative 2. And that would be point D. So pause the video and complete this guided problem, and we'll discuss the answers in class tomorrow. So now that we've completed this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.